Okay, we designed 20 practice problems associated with area, and I am going to go over the answers to all 20 of these problems in here. And I'm going to break it up. I'm trying to do about 5 problems per short video here. So let's get started. Here's number 1. So it says here, what is the area of a square with diagonal 20, radical 2? So there's no picture, so let's draw one to kind of see what's going on. And you have to know the vocabulary phrase for diagonal. Well, there's a diagonal. Well, hopefully you know the properties of a square. And we create 45, 45 right triangles when we have a diagonal of a square. And that's 20 radical 2. So the goal is to find the area. In order to find the area, we need one side. Well, all these sides are actually going to be the same. And if you notice, we can use our 45, 45 right shortcut to go backwards. We take 20 radical 2 and we divide by radical 2. That implies each side is going to be 20. So what's our answer? Well, all we need is one side, and we just square it to find the area of a square. In this case, we have 400. 20 times 20, 400. All right, let's take a look at number 2. Number 2 is also dealing with the square, but this time they tell us the area. So in this case, we know the entire area is 1,849 square units. And we want to find the perimeter. Well, once again, it would be nice to know this value in here. So if the area formula is side squared, and we already know the area, we can now solve for s. How would we do that? Well, we square root both sides. So when I take the square root of 1849 in my calculator here, we get a number that's 43. So 43 is not the area. 1849 is the area. 43 is the sides of all these of the square in here. Each side is 43. So make sure you're reading every problem carefully. Well, in this case, what's the perimeter of the square? The perimeter of the square is going to be 43 times 4. I got 172. Let's take a look at the next one. The next one still doesn't have a picture, and we want to know what's the area of a rectangle whose one diagonal is 85. And by the way, diagonals of a rectangle are congruent, so the other diagonal would be 85. And it says one side of the rectangle is 77. Well, I'm not sure which one's 77, but it's not going to make a difference in here, because when we find area, we just have to know the two sides. And so I have to find for this missing side in here, and I'm not going to use sine, cosine, and tangent. I'm not going to use a shortcut here. This is not a shortcut. What you got to use is Pythagoras. So hopefully you understand why Pythagoras works and in what situations it works in. It works for right triangles. In this case, I'm going to go 85 squared, and I'm going to subtract what? I'm going to subtract 77 squared. And when I take the square root of that number, I get a nice whole number. Lucky us, that is 36. So again, we're trying to find the area. What's the area of a rectangle? Well, it's length times width. So when I take 36 times 77, that's 2,772 units squared. All right, let's do number 4 in here. 4, we do have a picture, and I don't see a shortcut. I don't have enough information for Pythagoras. It looks like we have to use sine, cosine, and tangent to find this missing side over here. So how does 68, 44, and x, how are they related to each other? Is it sine, cosine, and tangent? Well, it is tangent. Why is it tangent? Because tangent's ratio is the opposite side all over the adjacent side. So when we solve for x here, we're going to go 44 divided by the tangent of 68, and we get this side to be 17.77715-ish. So once again, we're trying to find area, and to find area, we're just going to multiply those two numbers together. I'm going to get a nice decimal in here. This is 782.1947 units squared. Let's take a look at one more before we take a little break. Number 5. What's the area of a parallelogram? Well, you didn't really do this in middle school, so the area formula of a parallelogram is base times the height. Well, there's two ways of looking at this with the parallelogram. You could interpret this as the base, but then this would be the height over here. Well, considering we don't know that base and we don't know that height, let's not see the parallelogram from that perspective. What you got to do is turn your head sideways a little bit, and if we treat this as the base, look what happens. This number in here is the height of the parallelogram. So it looks like we don't know that side, but if you know the properties of a parallelogram, both pairs of opposite sides are congruent. So we actually have all the information to solve for this one. The base in this perspective is 60, and what's the height? It is 10. So in this case, it is 600 square units. All right, come back for more.